In this video, I'll be introducing how to do data exploration and visualization with scatterplots. So a constant question you're faced when you collect data is how do we visualize it? How do we select the correct graph? In previous videos, I've discussed I've discussed histograms, box plots, error plots, and those typically work when you have data that is divided up into separate groups. Now, scatter plots work when you have data that you have two numeric variables which you're interested in the relationship between them. I do have data here for two different groups, XX and XY individuals, but the main aspect of the data I'm interested in is the relationship between the x-axis variable and the y-axis variable. So in this particular data set, we're going to compare the mean of parent height against the mean of child height. So what this means, in particular for me, is to calculate the data point for myself is I would take my mom's height and I would take my dad's height and I'd calculate the mean or the midpoint between them. And then I would take my height of 5'10" inches and I would plot it there. So about 70 inches there. That's where I would be. So the midpoint between my parents and myself, and that's where my data point for this scatter plot would be. And this is the relationship that Galton was interested in when he was investigating his height data. So he's interested in how does the parents' height, and he figured that they were making a combined genetic contribution to their children. So how does their height relate to the height of their children? Because variation and heritability were key aspects of Darwin's theory. So when we make a scatter plot like this, it's often good to draw a line through it, or a trend line, or a line of best fit, and that summarizes the strength and direction of the correlation between variables. It's good to remember that correlation is not causation, though we have a pretty good reason to believe that the heights of parents are related to the height of children. There are other factors that could include nutrition, environment, environmental disasters, other things that impact the health and well-being of children. So even though the genetic contribution of parents has a strong influence on their child height, there are other reasons. So there is a pretty strong causal link between parent height and child height, but it's not perfect. And there are many times you will see a scatter plot like this where you cannot directly say what's on the x-axis is causing the y-axis. But again, a trend line draws through the cloud of data points that can help summarize the strength and relationship of the correlation between data. So if there is a positive correlation, the line goes up, the slope of the line would be positive. That means that tall parents typically have tall kids. So parents whose mean value was, say, 70, they typically have children whose height is around 70. A negative slope, I had to contort the data purposely because it's not an actual negative correlation, but that would mean that a downward sloping line would mean a negative correlation. This would mean that the biology was completely different, that tall parents would have short kids. If a line is flat, that means there's no correlation or no consistent difference or no consistent relationship between the data. Practically, that means that knowing the parent's height tells you no information, tells you nothing about what the children's height. A mean parent height of 68 could have children who are as low as 60 and as high as 75. So there's no consistent relationship there, no correlation. We can quantify what's going on in a scatter plot using correlation coefficients. They range from negative to 1, and they summarize the strength and direction of the correlation in a single number. So a correlation coefficient of 1 would mean a perfect correlation. That means that a mean parent height of 72 would result in always in a child height of 72. A negative correlation of 1, that would mean a perfect negative correlation of 1. That would mean that a parental height of 72 would always result in a child height of 65. Usually there is variation. You almost never see correlation coefficients that are even close to 1 using biological data. Usually there's a lot more variation there. So more generally, a correlation coefficient of less than 0 means that there's an overall decreasing trend, and a correlation coefficient of 0 or near 0 means that there is no consistent trend. There's no consistent correlation between the data, that the line drawn through the data would be flat.